Sir, good evening.
Good evening, Sarji. Good evening.
Good evening to all participants. Sir, can we start now?
Yes, sir.
Asmi ma'am, are you there?
Yes, sir.
Please start the session.
Yes, sir. A very warm welcome to everyone present here. I'm Asmi Jain, and it is my privilege to be today's program coordinator. It is with great delight that I welcome you all to this faculty development program on systematic approach to research paper writing. Our session today is led by our immensely knowledgeable expert, Dr. Krunal Soni, sir. The topic for today's session is hypothesis development testing. It lies at the very heart of impactful research. This event has been thoughtfully organized by the Research Foundation of India and RFI-CARE in collaboration with Shodh Malwa, Parul University, Gujarat, Eklavya University, JHERF, ARGA, and Edu Academic Inc. Now, allow me to introduce our esteemed speaker, Dr. Krunal Soni, sir. Dr. Soni is an associate professor of finance and accounting at the School of Management, GSFC University, and brings with him over 10 years of academic experience, completed by 2.5 years in the industry. He holds a diverse range of qualifications, including a BBA and MBA in finance, a PhD in management, diploma in foreign exchange and risk management, postgraduate diploma in research and methodology, and a BCom in accounting and taxation. Among his many accolades, Dr. Soni has received three Best Research Paper Awards at international conferences and has been guiding PhD candidates since 2022 at the Veer Narmad South Gujarat University. With such remarkable credentials, we are truly honored to have him with us today. Sir, may we now have the privilege of hearing from you?
Yeah, thank you, madam. Thank you. Yeah, just confirm the screen sharing. Okay. Yeah, I hope the screen is visible.
Yes, sir.
Okay. Okay, so thank you. Good evening, all. So the topic for today is hypothesis testing and design. Today we have to discuss about one of the important parameters as far as your research is concerned. So research has many parameters to take into consideration. But yes, one of the important part, as far as research is concerned, then it is the hypothesis testing and design. So basically, a hypothesis is going to be considered one of the important pillar, for the research. The reasons are many, and the points are many to remember. Because when we are testing hypothesis, is basically the assumption about the objectives. So objectives are very, very important to identify, you know, and one of the important question which I always came into my mind, before starting a session. So I just wanted to glimpse of it, why we are creating hypothesis. That means on which we are carrying out the particular study. So that we have to design the hypothesis and we have to test those hypotheses. What is the logic behind it? Anybody can answer on which study we have to design the hypothesis. So I'll give you an idea about it. Can we design hypothesis on population or we can design hypothesis on sample? Yeah, any answers from audience? Why we design hypothesis? Is it for population study or is it for sample study? Yeah, so basically it is for the sample study. The reason why it is considered to be sample study is because if at all you are considering population study, so that consists of, you are considering the study of all the parameters, into the consideration, while sample is the few parameters out of the population that we have taken out. And based on those parameters, we are making the study. So, uh, the hypothesis basically we have to taken up for the sample study. That means the few parameters out of the population that we have to take up, and that is considered to be the sample. And what, because hypothesis is usually carrying out on the population where, being a researcher, you are not in a position to have the proper understanding, the proper learning, proper investigation on all the parameters of the population, because somehow there are limitations to reach out on this parameter, and those limitations are related to monetary aspect. That limitation is related to the time frame which has been assigned to you, and this limitation is somehow about the richness in terms of those parameters. So there are many things that we have to see to it, and due to which the sample needs to be taken out of any of the reasons for which we have to test the hypothesis. And that's why whenever we are conducting any hypothesis testing and design for the study, those studies are considered to be the inferential statistics, right? So we need to understand what is the meaning of inferential statistics. So inferential statistics is basically concerned about whenever you are taking the sample out of the population, right? So whatever results that you are deriving out of this sample, so out of this result, you are making some inferences about the population based on the results that you have generated. So this is considered to be the hypothesis testing. So hypothesis, if somebody is asking you in a layman language, so the simple answer that you have to give for this hypothesis is considered to be the inferences about the population. So you have to make the inferences about the population. That is called hypothesis. Now, if we are consisting hypothesis, if we are making hypothesis, so we have to understand this, systematic way of writing literature review. So hypothesis is considered to be the middle point of any research. It is considered to be midpoint of any research. So if hypothesis is considered to be the midpoint of any research, so what is the before parameters of this hypothesis that we have to see to it, right? So if we are taking into consideration the hypothesis, can anybody tell me what is the procedure that you are making before the hypothesis designing? What is the procedure that we are looking for? Yeah, any answers? Which procedure we have to make it before hypothesis? So before hypothesis, we have to make the objectives, yes or no? Or in a different language, the hypothesis can be framed based on objectives, yes or no? Agreed? Fine. Before objective, what we are doing it, I hope I'm audible. Am I audible?
Yes, sir.
Yes, you are.
Okay. Right. So based on objective, what we are doing it? Before objective, what we are doing it?
Sir, we are formulating the
We are
research question.
identifying the problem.
Yes. That is called research gap, identification of problem. Perfect. Right. What we are doing before research gap?
Sir,
Literature review, sir.
Perfect. Systematic literature review. Right. Before literature review, what we are doing it? Simply we have title. Yes or no?
Yes, sir.
Right. So before hypothesis, you are doing this simple process. What process you are doing after hypothesis? Once your hypothesis has been designed, you know what you will do? You will frame a questions.
Hypothesis will guide us as a roadmap to go ahead for the research.
Yeah, so that is questionnaire, or else you will find out the variable for secondary data collections. Yes or no? Yeah.
Yes, sir.
So you will decide over here the variables also, if it is secondary research. Perfect. So based on questionnaire, you will have your data collection, right? Either through primary research in terms of survey, or whatever the data collection that you are looking for, from the secondary data sources through the online mode, right? So that is called data collection. Sorry, it is data collection. Clear? Based on data collection, what you will do? You will data analyze. Yes or no? And this data analysis can be possible with different type of data analysis tools and techniques. Based on data analysis, what you will do? You will interpret those data. You will have the interpretation of those data. You will try to interpret those data in terms of, acha, one more thing over here is, see the connection over here is, right? You have framed the questions. Can anybody tell me I have framed the questions, or else I have decided the variables for the data collection? Now the question over here is, if at all I'm collecting those data, so data has relation with what? How this data has been related? Which parameter? Data have been related with which parameter? Objectives. Yes or no? Because objectives will give you hypothesis. Based on hypothesis, you will identify questions or variable. And on these questions and variable, you have collected this data. Yes or no? And this objective have been framed based on research gap. This research gap we have identified from the systematic literature review. And we have conducted literature review based on the title we have decided. So ultimately, this interpretation that you are doing it is for the objective. And this objective is directly reflecting to the title of the study. Is it clear? And ultimately, interpretation, then you have to say findings and conclusion. So this finding and conclusion ultimately needs to represent the title of the topic, right? So ultimately, it should be a synchronization process between all the steps which we have mentioned over here, out of which the hypothesis is considered to be the center point over here, right? All these points should have a synchronization with each other. And ultimately, they should be the representative of the title of the research. Because ultimately, whatever findings and conclusion that you are deriving out of the research, it should finally reflect and conclude the title of the research. Otherwise, if your title is not going to be justified, it is not going to be matched, then the purpose of the research is not going to suffice, right? So here we have to see that, title should be justified based on the finding and conclusion. Sometimes, acha, one more thing, are you deciding title before writing a paper, or, you decide the title finally after having completion of the paper? What ideally we are doing it? If you are writing research paper, what exactly the ideal process you are doing it? No answers? What exactly we are doing it? Before proceeding all the research parameters, our title has been final, or after receiving finding and conclusion, we will finalize the title. What is the ideal process? So ideal process is based on finding and conclusion, we have to finalize our title, right? Whatever finding and conclusion that we have derived, based on which we have to have your title to be finalized, right? So that is where it should be the representative of all those parameters, right? So here we have to decide, whatever findings and conclusion that we have derived out of this findings and conclusion, we have to finally make our title to be, visible and available for the market, right? So that is how the complete synchronization process could be possible, right? So this is hypothesis testing and design. So what introduction is, the hypothesis is an assumption about the population, as I've already mentioned, because when the researcher is not in a position to study all the parameters of the population, they have to take some representative of the population. That means if I have, 5 lakhs of population, or let's say if I have 5 lakhs of population, out of which I'm representing 500 samples, so that means for every one sample, I'm representing 50,000 population, or sorry, 5,000 population, right? So if somebody is saying that instead of 500, I'm taking 1,000 sample, so obviously it is good. So instead of one sample, we are representing 2,500 population. So obviously the results which you are getting over here, is more representative of the population characteristics than the results which we are receiving over here. So obviously taking more sample for the more population is always going to be beneficial side as far as the acceptancy of the research is concerned, and to find out the more and more ground realities of the problems that we are searching for, right? But again, why it is considered to be the assumption of the population? Because as you can see this, we are noting that for every sample there is certain parameter of representative population. So it means that for one sample, we are making assumption, right? Whatever the result of one sample over here, we are assuming that next 2,500 people are also having the same assumption, same, thinking about this particular study, right? So this is called to be assumptions, right? That means we are saying that whatever this person is saying, same thing have been noted by this 2,500 population. So that is considered to be assumption, right? We are making assumption about this. And that's why we are saying that hypothesis is considered to be the characteristics of the population that can be measured in terms of mean and variances. So obviously, whenever you have to, measure the characteristics, so that could be measured in terms of mean and variances. And that's why, whenever you are going for, the detailed analysis of the result in terms of F statistics, Z statistics, T statistics. So everywhere we are using this mean and variance as a part of the parameters. And you can see this. Let's say if I'm using one pan sample C test, so this is one of the assumption over here. Let's say, can we have a mute, please? Okay. So let's say we have to assume over here that if I want to measure that, I have some mark sheet of the students out of 100 for the subject of accounting. And I have assumed that, based on the data sample which have it, I have received the average mark of the students is 81. So I'm assuming that, as a T statistics, that the null hypothesis is mu is equal to 81. That means there is no difference, right? If I want to write this in verbal form, so there is no difference, no difference in the average marks of students of 81. And on the contrary, the alternate hypothesis is, right, there is a difference. That means here we are saying that mu equals to 81 means the average marks of the students are 81, which is equals to average. That means no difference in the average marks. But here we are saying that the average marks mean is not equals to 81, means for every individual students, the marks is deviating from each other, right? So that is where we are saying that there is a difference, right? There is a difference between the average marks of the students of the accounting subject is 81, right? So there is no difference and there is a difference, right? So that is where we are seeing the marks of the students, So it always says that the study always begins with the assumption that null hypothesis, and this null hypothesis is saying that there is, no difference, right? That is mu equals to 81. And the alternate hypothesis says that there is the marks is not equals to 81. That means there is no difference, that marks is not equals to 81, and based on this, so there is a significance level. I hope you all are aware about the significance level. What is the significance level? What is significance level in social science? And why we are assuming to be significant level? What is the relation and what is the importance of this significance level?
Whether the value which came can be accepted or not.
Accepted or rejected, that is a result, madam. But why we are assuming this significance level? What exactly it is indicating in research? Why we need to assume significance level when we are taking hypothesis?
If
What
we
is the
consider
logic?
two variables, if both or gives if the both gives an approximate value which tells us whether the study is significant or not. So
Okay, fine. So I'll have some logic over here. So let's say we have 100%, the percentage accuracy should always measured in terms of 100%. So here we are assuming 5% significance level. So out of 100, if 5% is significance level, right? So what is this 95%? If you heard about it, we have heard this in our graduation, when we were student. What is this 95%? If 5% is significance level, then what is this 95%? I'm highlighting this. I hope you will get an idea what exactly it is said. If 5% is significance level, then what is this 95%?
Sir, if level of significance is 5%, that means there is 5% chance of error in the null hypothesis and 95% chance of being accepted that null hypothesis.
Perfect. So it is called confidential level. Confidence level. Yes or no? Pi is significant. So 95 is confidence interval. Yes or no? 95%, whatever result which I am producing with the 5% level of significance. So here I am committing that whatever result which I am giving you in terms of difference of opinion, they are 95% accurate. And that means I am assuming that there would be a chances of error of 5% in this study. There could be a variation out of the results which we are receiving in this study. So as and when you are a market researcher or you are a customer and you are planning to refer our own research, so you must have to take into consideration the 5% chances of error, right? That is called significant level. That means my result are 95% accurate. And if your p-value is falling less than 0.05, that means you are having the chances of error. And that indicates there is a difference of opinion. And this difference of opinion is nothing but the alternative hypothesis. Yes or no? We will also discuss about the acceptance and rejection criteria of null and alternative hypothesis in very next slides. But I hope this is clear. And usually, as far as significant level is concerned for the hypothesis testing and development, in social science, we usually keep the significant level to be 5%. Can anybody tell me why it is 5%? But if I recall, or if I have to mention over here, that for the same perspective, the significant level for the medical science is usually changed. It is considered to be 1%. Yes or no? Why it is 1% for medical science or biotechnology? Why it is 1% and why in social science it is 5%? Is there any logic behind this, or is there any foolproof criteria for taking 1% and 5% approximately?
Maybe the bias will be less in medical science than
Right,
this.
perfect. Bias means actually in medical
Error.
science there is no bias. We can call it as chances of error. The variations in the result, the deviation in the result. So medical science always tests on various medicines, and those tests usually happens on chemical, and the behavior of chemical are always in the certain directions. It is not going to change frequently. They have certain characteristics and behavior on which they will start working on it. But if it talks about on human perspective, the human mind, the human chances of errors are always going to keep changes, right? So human minds are always keep going to variation, right? And these variations are very frequent, and that can be influenced by anyone in significant time period or within short period of time. Even people who is speaking something else in the morning will change their opinion in the afternoon if they are in the influence of someone, right? So human behavior cannot be measurable, and the things which is non-measurable in terms of quantity, in terms of quantum, where the chances of errors are always going to be high, because you always have to believe on the qualitative data, and qualitative data has no scientific measurements to answer. And that's why social science is a qualitative field where human behaviors keep changing, perception keep changing, opinion will keep changing. So here you cannot take a surety about the individual's opinion, right? Even today some new things will come out, they will change their opinion, just like a Reliance Jio, right? Who has think about it that Vodafone will struggle a lot and they will die with the idea, and then it is turned to be Vodafone idea. And still they are struggling in the market to survive. So this is the matter of time, but yes, the people opinion keep changing. You cannot consider yourself to be 100% accurate in all the times. So that is where 95% is considered to be confidence level. That means whatever study which I am producing as a result, they have 95% accuracy in terms of producing the results to the market. I hope it is clear. Okay, now there is a discussion about the hypothesis acceptance and rejection, right? So firstly, whenever we are telling, we are deciding to test the hypothesis, the first and foremost aspect that we have to do is over here is we have to have validation of data, right? We have to validate the data in terms of, whatever results that they have generated. So before validating data, and this validation can be possible with the collection of data. And once the collection of data has been finished, you have to differentiate between the sample means hypothesized value and actual value. So you have to make a comparison between what assumption you have made it and what actual results that you have received it. And the comparison between these two will be the ultimate results for the hypothesis. And based on the p-value, the hypothesis testing will be judged. The criteria for judging the hypothesis is if the p-value is greater than 0.05. So this 0.05 is what? If we are assuming 5% to be significance level, right? So in decimal, it has been written like this: 5 divided by 100. So it is considered to be 0.05. Is it clear? In decimal, it has to be written 0.05. Fine enough. So if your p-value is coming like 0.01, 02, 3, 4, up to this, even 4 point, even you are receiving 0.49, then also your p-value is less than 0.05. So if your p-value is less than 0.05, you always have to reject the null hypothesis. That means they are falling into error term. They are falling into rejection region of null hypothesis. And if the p-value is falling into rejection of region of the null hypothesis, then you have to accept the alternate hypothesis, right? So that means if your p-value is less than 0.05, you have to reject null hypothesis. That means you have to accept alternate hypothesis. And on a contrary, if your p-value is greater than 0.05, so you have to reject, you have to accept all null hypothesis and reject alternate hypothesis. But we cannot say in research language that we are accepting, null hypothesis. But we have to write like we fail to reject null hypothesis, because the statement is always in the word of rejection. Either you reject or you fail to reject null hypothesis. So reject and null, these two should always be the part of in your sentence, whether you fail to reject or whether you reject. But to fail to reject means you are accepting null. And to accept the null hypothesis, your p-value should be greater than 0.05. That is, your p-value should be beyond your significance level. And if your p-value is less than 0.05, we fail to reject the null hypothesis. That means you are accepting. We reject null hypothesis. That means you are accepting the alternate hypothesis. Clear? And if the difference in the high in terms of mean rank, we conclude that difference is significant and vice versa. Right. So let's understand this p-value region. Right. So this is, I hope you all are aware about this bell-shaped curve. Yes or no? This is normal distribution curve, which is completely
Yes, sir.
bell-shaped.
Yes, sir.
Right. And this is minus infinity, where minus probability will be there, and this is plus infinity. Yeah. This is minus and plus. So your p-value can vary. Your chi-square value can vary from minus to plus region. This middle line is considered to be center point, which considered to be mu, right, is equal to 0, or x bar is equal to 0, right? So this middle point is considered to be the center point. So the left side of this side is negative infinity, and right side of this region is considered to be positive infinity. Now the question over here is, if your p-value, so these two regions, this region are considered to be, if you come to 0 from minus side, if you move on this side on the minus region, your values are getting increased. Your values are getting increased. So if you are getting less than p-value 0.05, then they are falling into this region, right? And if your p-value is falling over here less than 0.05, then they are falling into this region. In short, whenever your p-value is less than 0.05, so they are falling into either this region or they are falling either this region. So both the regions are considered to be rejection region of null hypothesis. Both the region are considered to be the rejection region of null hypothesis. That means you have to reject the null hypothesis. So if you are rejecting null hypothesis, so to whom you are accepting? H1. Right. So you must have to remember, whenever your p-value is less than 0.05, you are accepting the statement of alternate hypothesis. Is it clear? Everyone, it is clear? Any doubt? Any sort of doubt? If you have it, please let me know.
So please explain type 1 and type 2 error.
Type 1, type 2 is, there is no relation in the, research especially. It is a theoretical ground, it is okay. But if you have to, it's very fundamentally and it is very clear. I'll explain you, by going into website and I'll detailedly explain you. Type 1, type 2 error is nothing more to do with the research. Ultimately, the research has major crunch and the major justification in terms of, p-value, acceptance and rejection criteria. Because whatsoever test you will apply, either you are going for normality testing, either you are going for parametric testing, non-parametric testing, even you are going for exploratory factor analysis, confirmatory factor analysis, correlation, regression,
Excuse me,
everywhere.
sir.
Yes.
Which test we should apply? How we can decide this?
Where
We
which
have
test?
to apply which type of test? ANOVA, chi-square, or t-test? Which test we should apply on the data? How we can decide this?
It is based on data characteristics, right? Let's say if I have to apply regression, right? So although this is a different session that might be covered in this FDP, right? So if we need to apply regression, so there are three types of data in SPSS. So first is nominal type of data. Second is ordinal type of data. And third data is scale type of data. Right now, regression over here is, so there is dependent variable in one way and another one is independent variable. So based on which the regression formula is y is equal to alpha plus beta x1. Yes or no? Where
Yes, sir.
x1
Yes.
is independent and dependent is y. Right.
Yes,
In
sir.
both the cases, actually with this equation, what we are doing it, we are checking the impact of x1. We are checking the impact of x1 on y.
On Y.
That means if any changes happening in x1, what would be the result of y? Right. So that is called y is equal to alpha plus beta x1. Right. If
Yes.
any movement, if I'm making in x1, what is the impact on y? That is called regression. So if at all I need to make any movement in this particular variable, for which I need the data in terms of pure numbers, right? Pure natural numbers. That is called scale data. So SPSS consider the pure number data to be scale data. Right. So SPSS considered the pure number data to be scale data. So if at all you need to go for regression, you have to have scale data. Right. Understood? Depend
Yes,
on
sir.
this,
Yes,
let's
sir.
say if you want to go for parametric, non-parametric. So again, in parametric, non-parametric, there are many cap, let's say if you have to go for one sample t-test, independent sample t-test, so one sample t-test, right? So one sample t-test can be applicable again on scale data where you have only one variable. Let's say we have seen one example before, in the previous slide, that is a marks of accounting subject. So if I have the marks of accounting subject, I'll take the mean value of that particular subject. And then I will try to see that, thus the result is deviating from this mean value. So if the zigzag in the values are high, that means you will show the deviation, but if zigzag is not high, you will not show the deviation. So how the zigzag is high and low will be measured. So here you can see this acceptance region. So if your p-value is greater than 0.05, so usually you are falling into acceptance region, and this acceptance region is nothing but about H0. So obviously when you are looking at this bell-shaped curve, You are looking at the rejection region and acceptance region with the favor of H0. So this is the rejection region of H0. This both the sides. And these regions are the acceptance region of H0. So if I was talking about the accounting subject mark, if the zigzag in the subject is like this, if this subject marks are behaving like this, so this is called deviation, right? And if the mean value is going like this, H181, so you can see this one variable is over here, second is here, third is here, fourth is here, fifth is here, sixth is here. So they are more deviating from the average, as you can see this, right? So in this case, you cannot say that there is no difference in the average marks and the actual mark which has been received, because there is much deviation. So in that case, you have to mention that there is a deviation, and in that case, statistically, your p-value will always comes less than 0.05 automatically. And there is an inverse relationship between the different tests you are applying on the statistical front. Let's say you are applying H test, Z test, T test, F test. So whenever you are receiving high F statistics, S statistics, T statistics, you always see to it your p-value is going to be much lower, and much lower means it is reached to the less than 0.05. And if the p-value reach less than 0.05, you are falling into rejection region of null hypothesis. And if you are falling into rejection of null hypothesis, your alternative hypothesis says that there is a difference. Whatsoever test you are applying immaterial, but alternate hypothesis is only one statement that there is a difference, there is an impact. Is it clear? Understood?
Yes, sir. Thank you so much, sir.
Yeah. So different test-wise hypothesis, you can see this. Here you will get better clarity. So here I have applied normality statistics. So obviously one thing you always keep in mind that normality statistics can be applicable on scale data, Likert scale data or like a pure number. It cannot applicable on nominal data. Let's say I cannot find out the normality for the genders, right? Who is falling into male and female, right? So normality can, normality testing cannot be applied on nominal and ordinal data. It always applied on scale data. And Likert scale is one of the part of it, right? Likert scale is one of the part of it where we have to apply the normality test. Clear? So here the normality test, whenever you are applying, the hypotheses are obviously reverse. Like if you are applying null hypothesis, so it says that data are normally distributed, and if you're applying alternative hypothesis, it says data are not normally distributed, right? And again, the acceptance and rejection of p-value is same. Always whenever you are applying any sort of test in hypothesis, right, the acceptance and rejection criteria are common, whether you are applying normality testing or whether you are applying inference statistics, right? The acceptance and rejection criteria for the hypothesis is common. And if you can see this, for every test, you have to see the significance value. This significance value is representing p-value, This is p-value. Okay, now you can see this. Is this p-value is greater than 0.05 or less than 0.05? Is it greater than or less than?
Less than, sir.
Less than. Perfect. So if this is less than 0.05, right, it is less than 0.05. So which hypothesis got accepted and rejected?
Rejection of null hypothesis.
Perfect.
Rejection reason.
Perfect. Rejection of null. So which is going accepted?
H1.
Obviously, you have only two options. If one is rejected, other is accepted. But you should know which one is rejected initially. So rejection criteria for null is
H note rejected and H1 accepted.
yes. So the rejection criteria for H note is less than 0.05. If
Yes.
let's say if this p-value will turn 0.100, right? So this p-value is greater than 0.05. So in this case, it is acceptance of null hypothesis and rejection of alternative. So if
Yes.
this is the value which you will receive over here, then you can say this, your data are normal because you are accepting null hypothesis. But here you have received this value, which is less than 0.05. It means you are rejecting null hypothesis and accepting alternative. That means your data is not normal. Your data is not normal, right? So this is how the hypothesis needs to be tested, and you have to give your judgment, right? And if the data is normal, for the further evaluation, you need to go for parametric test. I hope you all are aware about it. What is parametric test? And if the data is not normal, you need to go for non-parametric tests. Is it fine?
Can you explain what is parametric and non-parametric test?
Parametric test is usually consists that data are usually normally distributed like this bell-shaped curve. That means your data is usually falling into this area. It is normally distributed in a manner it has to be, right? And for this, you have to go for parametric. So usually parametric tests are working on mean value. I hope it is clear. Mean comparison of all the data. You can see this. We have taken this over here. So this is mean comparison. This is actually one sample t-test. Actually, it is one sample t-test. Clear? So it is usually working on the mean value. While if you are going for non-parametric, when you are going for non-parametric, they are working not on mean value, but they are working on mean rank value. They are working on mean rank value. Is it clear?
And what is the mean rank?
Mean rank means, let's say if I have, let's say this is a mean for this, this is mean, right? So I can find out the highest mean over here. And you can see this 0.362 is highest one. So I'll give first rank. Then the second one is 0.722. This is 2 rank. And then the comparison will be made as far as normally non-parametric test is concerned. While if I'll talk about parametric test, so they are not working on rank, but they are actually working on these figures only. Just like this.
Okay, thank you.
Okay. So this is how parametric test, which I was talking about. So let's say this is independent sample t-test, which test is going to be applied on, there are two assumptions. One data should be nominal and another one should be scale data, right? So firstly, we have to see the equal variance assumed. So here you can see the hypothesis. So in the world, there are two hypotheses where null hypothesis is going to be positive. For one, it is normality and another one is variance. In both the assumption, we are assuming that the null hypothesis is positive. So null says that data are normal in normality, and in variance, it is assumed that equal variance assumed. While in alternative, we are assuming that data are not normally distributed and alternative equal variance not assumed. Clear? With the consideration of p-value over here. Right? Understood? So here also you can see this p-value 0.000. So which hypothesis got accepted? Is it greater than or less than 0.05? By looking this.
Sir, please repeat again what you have
Is it
asked.
greater than or less than?
Less than 0.05.
0.05, right? So is it going to accept null or alternative?
It is going to reject the null hypothesis.
No.
Null is rejected and alternative accepted. So if you can see over here, with this consideration, with the variance consideration, now we will talk about this assumption. So whenever you have to see this assumption, so you have two options. Either you will see the result of equal variance assumed over here, and if not equal variance assumed, then another option is equal variance not assumed. So which results we have to check? For that, we have to first see this equal variance assumed. And over here, by looking at this value, we found that equal variance not assumed, because here we have accepted this alternate hypothesis, and alternate hypothesis says that equal variance not assumed. So instead of looking of this value, because this value represent a null hypothesis and this value represent alternate hypothesis. So alternate is accepted. So we will accept this value as a 0.000. Again, inferential statistics, this hypothesis, you can see this value is not important for us. So this value again 0.000, is it greater than or less than 0.05? Is it greater than or less than?
Less than, sir.
Which hypothesis got accepted?
Null hypothesis.
Alternate.
Alternate is accepted and null is rejected.
Null is rejected. Perfect. So null is rejected and this is accepted. Hence we can conclude there is a significant difference between the mean population. Clear? So if this is a result, I can assume that there is a significant difference between the mean population. Clear? And I told you one person has asked me that what is the difference between parametric and non-parametric. So I had answered that parametric test is working on population mean and non-parametric is working on mean rank of population. Yes or no? So you are in the parametric test and you can see
Yes,
this.
sir. Yes, sir.
Clear, everyone?
Yes, sir.
Any query up till now?
Sir, would you please explain what is mean rank of population?
I had explained. No, you just have the 100 people mean rank, and you just give the rank from highest to lowest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So usually, parametric is identifying the difference in the mean value of the population, right? While non-parametric is not identifying the difference in the mean value, but they are making hypothesis no difference between the population mean rank instead of mean. Is it clear? And based on that, the acceptance and rejection of the null and alternative will be decided with the consideration of p-values. I hope it is clear.
Yes, sir.
Okay. Over here, you can see this. This is ANOVA. And you can see this p-value again, significance value. By looking at this value, what is your assumption? It is greater than or less than 0.05?
Less than 0.05.
How, madam, it is less than? It is 0.3.
Greater than greater than
Right.
0.05.
Which
0.05, where the first place value over is 0. Here it is 3. So obviously it is, greater than 0.05. So if
Yes,
it is
sir,
greater than
greater than.
0.05, which hypothesis got accepted?
Alternative null is accepted.
So for this, there is no difference in the population for the online banking factor. Let's say if this is the case, then it is greater than or less than. If you
Less
are very
than.
smart, right, and in the moment you
than,
have
sir.
to make a decision, you see this out of these two, which one having the more zero over here? Sorry, this is 0.05. So here it is 2, 1, 0 in the place. Here I have 2,
Less
0.
than, sir.
Less than,
So obviously it
Less
is less
than.
than. Yes or no? So if
Yeah,
it is
less
less
than.
than, which hypothesis got accepted?
Alternate hypothesis.
Accepted H1.
So alternate says that there is a difference in opinion among the groups. And you can see this mean, because ANOVA is a part of parametric.
G, sir.
Is it fine?
Yes, sir.
Okay. And if you find that, in ANOVA, that this is a significant difference. So if you want to see that, let's say I have collected few age groups of people, 0 to 20 years, 21 to 40 years, 41 to 60, and more than 60. So if at all I want to find out which age group is having a significant difference for this, factor of user friendliness for the online banking. So I can go into this and I can find it out. This is post hoc test. This is post hoc test. So if I know that for this factor, the age group is having difference in opinion. But if at all I want to find out that these are the age group which I have asked as a respondent. So if I want to see this, which particular age group is making difference of opinion, so I will check the mean value, mean rank. I'll check the post hoc value. I'll check the post hoc value with the p-value, and you can see this out of this. This is greater than or less than. This is significant value, right? Or post hoc. You can see this significant value. So post hoc says that no impact or no difference for null, right? For null, it is no difference for this particular age group, and for alternative, there is a difference, right? So if I look at this age group of 21 to 30, what you will find out? Is it a difference or no difference? No difference.
No
Why?
difference.
Because
No
it is
difference.
greater than 0.05.
Greater than
So null is
0.0.
accepted. But if I come over here, it is
H1 accepted and there is difference.
they are making, so these people are making highest difference of opinion out of all the age group for this factor of online banking. So I consider that above 60 years of people are having difference of opinion in compared to other age group for the factor of user friendliness for the online banking. And over here also you can see this, the software has also provided the asterisk on the values. You can see this, the person who is making difference of opinion, they have provided asterisk, and you can check the p-value as well.
What it mean actually, sir?
It means that these people are making difference of opinion, and these people is having the p-value less than 0.05. Here they are making significant difference of opinion. Understood?
Yes, sir.
Yes, sir.
Same way, if you go to over here, you can see this. This is paired sample t-test, where I have to check one variable in terms of before and after scenario. Let's say if I want to check the sports person, long jump size. So what is a long jump for sports person before training program and after training program? So this is the result which I have get it in terms of significant value. So it is greater than or less than 0.05. So the null hypothesis is no difference in the jump size, before training and after training. And H1 says that there is a difference in the jump size before and after training. So if you look at this p-value, is it greater than or less than 0.05?
Less than, sir.
So which hypothesis got accepted?
H1.
Alternate, sir.
So is it difference in the jump size or not for before and after? Obviously, because you can see
Yes, sir.
this, right? So you can see this, there is a difference in the jump size because you can see the deviations. Clear?
Yes, sir.
So thank you so much from my side. Now I'm making the stage open for question answer. If you have any questions, you can ask. I hope you got the clarity what we have discussed today.
Yes, sir. You have explained in a very clear and concise way. So thank you so much.
Thank you. Thank you.
Sir,
Are
would
there
you
any
please
give a brief
Sorry?
explanation? Would you please explain about the types of data? Like,
Madam, types of data, we have usually 4 types: nominal, ordinal, interval, and ratio data. Right? If we talk about nominal, so nominal data are usually categorical data, but where the sequence does not matter. For an example, if I'm asking someone, what is your gender? So gender has 2 options. One is male and female. But when I'm preparing my questionnaire, does it any logical sense that I should put male to be first and female to be second? I can make anyone, right? Let's say if I'm male, I will put male first. You are female, you will put female first. But there is no certain criteria for male and female to put this criteria to be first. So that is called nominal data is categorical data where sequence does not matter for the option is nominal. For ordinal, again, it is categorical data, but where the sequence does matter. Let's say if I'm asking someone to be age and I'm converting into age bracket 0 to 20, 21 to 30, just like we have seen in the slides. So if you are being a respondent, you are answering for one questionnaire. So you expect that, if you are asking age, so it will be in a sequence like 0 to 20, 21 to 30 and so on, where the sequence cannot be in a jumble manner. Right. So it is a perceived opinion that it should be in sequence. So it should be in logical order. So that is why it is ordinal data. Right. Interval data usually start from zero. Again, it is a categorical data. Usually the students mark it in terms of CGPA gradings. In excellent category, outstanding category, good category, scope of improvement with the consideration of percentage. Right. But the same thing if you want to ask in terms of numbers, so you can ask in terms of, direct answers like what is your percentage, 68, 78, 84, where the pure numbers will come into picture. Stock market data, profitability data. So these are the scale data. Even Likert scale data is a part of scale data. So there is pure number. So that is scale data. Yeah.
Thank you, sir. Yes, sir.
Sir, can we have the recording of the session or PPT available?
You have the recordings. You have the recordings on YouTube, right?
Thank you, sir.
Okay. Any more questions? But I hope you got the clarity for the session today.
Yes, sir.
Are there any more questions? Anybody? So shall
Any
we end the
questions?
session then?
Yeah, please. Anyone is having session questions or any queries, you can ask, or else we can end up.
Sir, how far this data analysis test will be selected? Like we have chi-square test, t-test, and so on. So how those will be selected based on the variables or under
See,
what?
every test has a criteria to apply in terms of data. Let's say you are talking about chi-square test. So chi-square test is a test where you cannot have the scale data. Either it should be nominal and ordinal. So chi-square test is basically for categorical data. So whenever you are applying, rather based on data, you have to apply the test. I cannot say that based on test, I should have my data. But whatever data you have collected through the questionnaire. So this is a brainstorming session of research which has to be conducted. That's why I told you, in the first slide of my introduction, it is a synchronized process. I cannot say that I have collected data and then I'll think about it, what type of test I should apply. But this should be decided well in advance at the time of literature review and objective framings, right? And the variable selection. If your variable has been selected, the data has been collected, and then you feel that I want to go for advanced study, advanced research, advanced statistics, and you don't have the options or backup to come back. At that time, you have to sacrifice, or you cannot go to the respondent again to ask, the questions and data in different forms of data. They will not answer somehow, or you will not be able to collect from 500,000 respond to contact again and, collect those data, and a lot more justification you have to give it, so you have to decide what sort of test you want to apply, and based on that, which data I need to have it, and based on the type of data which you require, you should frame your questionnaire. And that is why I'm saying, research is a scientific process. So before and after everything, you have to think at every stages.
Yes, sir. Thank you.
Yeah. So any more questions? Okay. So thank you so much to all the audience for patient listening and making this session very interactive. Thank you, RFI team, Ajay sir, Asmi Jain madam, for coordinating this event today. And thank you, RFI team, for inviting me. Thank you, all of you. Over to you, madam.
Yes, sir. So, on behalf of Research Foundation of India, I would like to extend a heartfelt gratitude for such an amazing and insightful session. It was a really interactive session. Thank you for your knowledge.
Thank you.
I would also like to thank all the
Thank you, sir.
participants for their active participation. The recording of the session is available on YouTube. Thank you, everyone.
Thank you, sir. Thank you, ma'am.